Now let's look into the third technique of data reduction, that is a dimensionality reduction. So data reduction techniques, or you can say the dimensionality reduction. Dimensionality reduction involves reducing the number of features or variables in a data set while retaining important information. So this is commonly used in data sets with a large number of features to simplify the analysis and improve computational efficiency. So there are two main types of data reduction. There are two main types of data reduction or dimensionality reduction techniques. One is feature selection and second one is feature extraction. So, in feature selection techniques involve selecting a subset of the most relevant features features are variables from the original data set. Feature selection, the name itself is conveying that feature selection techniques involve selecting a subset of the most relevant features or variables from the original data set. These techniques aim to retain the most informative features while discarding irrelevant or redundant features. So, common feature selection methods include filter methods. So, these methods evaluate the relevance of each feature based on statistical or information theoretic measures and select the top ranked features. Example including chi-square test, information gain, correlation coefficient. We have used all these techniques. Then we have wrapper methods. Wrapper methods, these methods use a predictive model to evaluate the performance of different feature subsets and select the subset that results in the best model performance. Examples include a recursive feature elimination. We call it as a RFE method in data science. Recursive feature elimination and forward or backward selection. So what wrapper methods do? Wrapper methods use a predictive model to evaluate the performance of different feature subsets and select the subset that results the best model performance. So this is called wrapper methods, and some of the examples for wrapper methods are recursive feature elimination and forward backward selection. And the third technique here in feature selection is embedded methods. So embedded methods, so these methods incorporate feature selection as an integral part of the model training process. Examples include lasso regularization, decision tree based feature selection. Even decision tree is also used for the feature selection. So let's repeat this. Embedded methods are nothing but these methods incorporate feature selection as an integral part of the model training process itself. So you don't need to do a specific a method. You don't need to use a specific method to select the features. So example, if you take a decision tree model, so it comes up, it's embedded, it will have an embedded methods to select features. So these are the three techniques which are used in feature selection. Then we have the second one, that is feature extraction. In feature extraction techniques involve transforming the original features into a lower dimensional representation. So these techniques create new features that capture the most relevant information from the original data set. So what is feature extraction? I'm going to repeat it one more time. feature extraction techniques involve transforming the original or existing features into a lower dimensional representation. So, some of the examples for feature extraction techniques are principal component analysis, singular value decomposition, T-distributed stochastic neighbor embedding. So this is another example. Let's look into them one by one. So first one is principal component analysis. PCA is a widely used technique that reduces the dimensionality of the data by projecting it onto a lower dimensional space while preserving the most important information. So PCA creates new features called principal components. The features which are created by principal component analysis are known as principal components, which are linear combinations of the original features only. So which are linear combinations of the original features. So here then the second one we have is singular value decomposition. SVD. SVD is a matrix factorization technique that decomposes a matrix into three matrices, including a low rank approximation of the original matrix. So SVD can be used for dimensionality reduction in various applications such as image and text processing. This is very, very important when it comes to the computer vision and NLP. So, PCA can be used for normal data, other text, other data, numerical data. But when it comes to the uh, image and text processing, SVD helps a lot. Singular value decomposition. SVD is a matrix factorization technique. It is a matrix it's a matrix factorization technique that decomposes a matrix into three matrices, including a low rank approximation of the original matrix. That's what is our SVD. Then the last one in feature extraction technique is T distributed stochastic neighbor embedding. In short, we call it as a TSNE. So TSNE is a nonlinear dimensionality reduction technique that is particularly useful for visualizing high dimensional data in a lower dimensional scatter plots. So TSNE maps the original features to a lower dimensional space while preserving the local neighborhood relationships. So before we move on to the benefits of dimensionality reduction, I would like to take you through some of the important aspects of PCA dimensionality, component analysis, and other thing. So first, let's begin with the PCA. So PCA, obviously, no, if you want to use a principal component analysis, this method should be imported from, let me put it here. So dimensionality reduction. Okay, for PCA, principal component analysis, now we have to import PCA module, PCA method from sklearn dot decomposition. You see decomposition. So that's what we will be doing here. Decompositing the bigger data set and import PCA. So once this has been imported, so then you can use the respective, now how many components you want to make and all that information, you can take it and you can further reduce the dimensionality. And the second example we have here is singular value decomposition. This is very, very important. Very, very important. We want to, this will be used for the computer vision. We will be using all these techniques when we enter into the machine learning. That's why I don't want you to overwhelm with a lot of information in descriptive statistics only. I just want to give you the broad picture of data dimensionality reduction. The second one here we have is the singular value decomposition. This is called SVD. So SVD, we have to import from scipy dot linalg. You see that linalg. From this import SVD method. So that's where the single value decomposition. Here what it will do, we have to, if you want to perform SVD on the data set, then you have to convert that data set into 3S and VT. So 3 smaller matrices from the bigger matrices. So that's what you will do. Okay. So this is what we will do here. Okay. Then after that, the reduced data set with reduced dimensionality, will put it into as a, we will write down all different data sets. Then one more thing that we have here is feature selection. For the feature selection, we can use for the feature selection we can use a select k best method from the. So for the feature selection, of course we have seen feature selection and feature extraction. For feature extraction, we used PCA and SVT. So SVD, now for the feature selection, we will be using one specific method from sklearn.feature extraction or feature selection. I'll select the feature selection and then import select kbest. Select kbest and also mutual information. Mutual info class if. So using these methods, we can do the whatever, how much ever number of features you want to select. You can select by giving the value k is equals to 10, and then you also has to give the dependent variable. So based on that, it will select the best possible features for you. So this is what the feature dimensionality reduction and their methods to use in practical and real world data sets.